Welcome, Casey. So great to have you here in Hamburg. I hope you enjoyed already the first time here. And the first question I'm having for you is you are really from the early days on in the container and cloud native space. Tell us, how did you came to this? How did everything started?
The best answer is luck. Because you could have picked at that time OpenStack. You would have felt like you were right. You could have picked Cloud Foundry. You probably would have gotten promoted. You could have picked Mesos because that was the biggest project at the time. Big companies like Apple were using it and talking about it. And so for me, my background, I come from Pupper Labs and configuration management, working in enterprise, just trying to automate things. And then I was at CoreOS. And CoreOS was building our own container infrastructure based on Docker operating system. And then one day we get a call from Google saying, tomorrow we're going to announce a new project and you can't talk about it until tomorrow. They gave us a copy of the press release. They also gave us access to GitHub before it became public and said, you will learn about it tomorrow with the rest of the world, and then you can write your own comments. And being at the small startup, CoreOS, we probably only had about 15 to 20 people at the time. I was like, Google's going to make it a press release. We should do something more than that. And so that night, I ran through the code base. I got everything to compile because there were no instructions really. Got it working on CoreOS. And we had to do a few bug fixes to make everything work. But the next morning when Google posted their press release, we proposed a tutorial. Here's how you run Kubernetes on CoreOS. And we were smiling because on Hacker News, Google Cloud, their blog post was number 2, CoreOS was number 1, and so we stole their thunder.
I didn't know that you were from the really first day when it was public working on this. And how did you see Kubernetes evolving in the first years? So what did you saw? Did you directly saw the potential of Kubernetes, or what was your view? Because I know at CoreOS, I wouldn't say you built an exact competitor, but it was going in the same direction. I think it was called Fleet, what you're building there at CoreOS.
Yeah, but this starts way before. Like I said, if you were a system administrator and you did anything with VMware, if you did anything with the cloud, you saw this problem the whole time. You have an app, maybe using RPM, maybe using Puppet, Chef, Ansible. Some people were using Terraform. Either way, we were trying to build this, but no one had that kind of experience unless you worked at a place like Google or Facebook that had these kind of systems. And so when Docker took off, when Kubernetes came out, just seeing how the API spec worked, running kubectl apply for the first time, you kind of knew that this was what you were trying to build. You just didn't know how to articulate it this way. So at CoreOS, when we were building Fleet and Rocket, which is our container runtime, I worked on CNI, the container networking interface. We were doing these for very generic reasons, to be compatible with Docker Swarm, to be compatible with Mesos. There were so many projects, there was no clear winner. Matter of fact, at that time, Microsoft was saying when you went to their platform, you can have all 3, Nomad from HashiCorp, Docker Swarm, or Mesos. No one picked a winner. And so in those early days, it was just opportunity. Kubernetes had no volumes. There was no node management. All these components were not there. So we were looking at it, and I made a decision that I was going to contribute even before CoreOS was on board. It wasn't like we saw it and said, all right, we're going to stop Fleet. We're just like, maybe they will compete side by side. So nights and weekends, I was contributing. So I think a lot of the Kubernetes community were independent people liking what they saw and decided to contribute. And I was one of those people. Maybe 3 months later, it was like, yo, this is going to be the future of what we've been trying to do. And so CoreOS made its own pivot to make Kubernetes the default.
And what was the main point where you would say Kubernetes became the main way how to do this? Exactly as you said, at the beginning there was Docker Swarm, Mesos, Kubernetes, Nomad. And what do you think were the pivot points where it's cleared out more or less the majority will go with Kubernetes?
In my opinion, is when Microsoft announced support for Kubernetes and ended support for all the others. Because during that time, it wasn't clear. And so a lot of the other startups started to run out of money. If you were Mesosphere, you were having a hard time trying to figure out how to compete. The Cloud Foundry people were still on the fence about this is too complex. Most people just want a platform. How is Kubernetes helping with this? And I think a lot of people at Cloud Foundry ignored Kubernetes for a long time because they thought that it was just the inside of Cloud Foundry and not the developer platform. Brendan Burns, one of the co-founders of Kubernetes, left Google and went to Microsoft. And not long after, they announced support for their own Kubernetes offering. That was the moment, because you know what it takes to have a big competitor agree to use the same standard as their competitors. And that was the moment. Some people will say it was when Amazon did it multiple years later, but Microsoft was, to me, the signal. Because as a cloud provider, when you say you're going to support Kubernetes, that's a 10-year commitment. You can't just do it for 1 or 2 years. You have to support it for as long as your customers are willing to pay for it. That was the turning point, in my opinion, of when I thought that this thing is probably here to stay, whether people like it or not.
Remember me, during that time, you were still at CoreOS or already at Google?
I was at CoreOS for at least a year, because when I started, you got to remember when Kubernetes came out, even I thought it wasn't going to work like this. We didn't think it was going to be here for 10 years. We thought it was like a cool project from people who have experience building projects like this. And so when I was giving talks, I was just like, hey, there's a thing I'm working on. It's called Kubernetes. And then you would show it to people, and then they would get excited. That's how it went. There was no master plan. I hear people say, oh, Google had a master strategy. There was no master strategy. The strategy was to build something useful and see if people would like it. And then some of the contributions that I made included telling people what it was. Here's how it works. Here's what you were doing before. Here's what you can do now. And I remember so many people just watching those keynotes and those presentations, going to go build their own projects, contributing their own things, writing their own documentation, and it took a life of its own. And from there, you started to see the existing vendors come over, like the VMwares. You started seeing Cisco and everyone saying, this thing has momentum. We need to jump on and figure out what our story is.
And I mean, I think you also had a big contribution that Kubernetes became so successful because you did a lot of talks. Before you started with Kubernetes, were you already on this way and like doing a lot of talks about Puppet, for example, or?
I used to contribute to Python in 2005. I used to work on disutils and virtual env. If there's any Python people in the audience, you know what those tools are. No one knew who I was. You were just working on a tool that you had a problem with. I used to use Puppet in production in a financial institution. And then I went to give my very first talk in front of lots of people in 2012. And that same week, I got a job offer from Pupper Labs because it was their conference. It was the Puppet Conf in 2012. And as I'm working there, I kind of knew everyone from doing contributions in open source. But the thing we learned at that time, when you're working on something, it doesn't mean anything unless people know about it. So if you were an engineer at Puppet, the best thing you can do, and sometimes I would do this on purpose, there's a feature that I want to add. And the way we did it is you have to have the community vote. The best way to get the community to vote is you have to have a campaign. Hey guys, here's the feature. I would like you to upvote it in the ticketing system. Here's how it works. Here's a little bit of demo. And then you get all the plus ones. And then that would break the tie on what makes it work. And so you have 10 years of that first. And so I think I built up a bit of community trust. And when I was showing people Kubernetes, I was always starting from the bottom. And I was showing you it in a very pragmatic way. If you're a system administrator, here's how it works, in very detailed that, oh, maybe this person does the same job that I do. And I think that's where the credibility came from, because Kubernetes had no credibility of its own yet. So maybe I was able to lend mine, and I was talking about it in a way others would not. Some people started with the white papers. Here's the Wrath algorithm. You can read the white paper. You can use etcd. If you went to computer science school, maybe you understand what this means. But I was showing people as like, here's a bash script, and work our way up to Kubernetes to understand all the components. So I think that's kind of how my influence became viable for the community, because I was meeting people where they were, showing them what was next.
Yeah. I mean, I remember when I started with Kubernetes, there were not really installation instruction, anything there. There was just a few binaries, and then it was like, okay, you need more or less figure out on your own, like how to get the stuff running. I think you did one good way, Kubernetes the hard way. How did you came up with the idea to really have an end-to-end description, like how to set this up? And I think where it was really beneficial for new people was like learning all the insides of Kubernetes, because for a lot of people at that time, and I think nowadays, it's still a lot of magic how all the components working, and knowing exactly the details inside of Kubernetes, how everything fits together, that you get this up and running.
You gotta remember, during this time, everyone thought all platforms would look like Heroku. Again, Cloud Foundry, everything was about easy, easy, easy. And when Docker came out, they made a lot of things easy until they got to multiple machines. And then you had Docker Swarm, which was also trying to make things easy, but making things easy made it hard for them to do very complex things because they shied away from complexity in favor of easy. And so Kubernetes was trying to compete with Docker Swarm level of easiness. And so we had this script, it's called kubeup.sh. We ran this script, and it started creating machines and installing things, and it could break, and then you have to start over because we were trying to make it easy. To make it easy, we had like a billion-line bash script that tried to do all the magic. But the thing is, if you did it that way, you could never fix it because you had no idea how it worked. And so one day, at this point, I'm at Google, and we went to DockerCon. We're all sitting in the audience looking at Solomon introduce Swarm v2. And they were showing all of these Kubernetes features, and we were just sad because they kept adding things that we thought made Kubernetes unique. They added volumes, they had state management, so that way you can say something like Docker run, delete all the nodes, bring it back up, and all your apps would start again. And so we thought that we had lost our edge, and it was easier to use. So the team, we had an engineering offsite at Google, and everyone was panicking, like, oh my God, this thing is not going to work. Docker is running away with this thing. And I said, hey, I think the reason why people keep saying Kubernetes is complex, because they don't understand it. Linux is complex. Your shell scripts are complex. Your entire infrastructure on-prem is complex, but most people don't say that. And so I was like, maybe one solution would be, how about we show everyone exactly what to do without any scripts, manually. And it turned out, when a lot of people went through Kubernetes the hard way, especially if you were a system administrator, you're like, oh, this is how it works. There's binaries and config files. You start them in this order, and when you're done, you can run apps on them. And at that moment, Kubernetes is still complex, but at least you understand it now. And that was a big thing for a lot of companies. So if you were working at GitHub and you were an engineer, how else were you going to learn Kubernetes? That's how a lot of people learned Kubernetes and customized it, and then became contributors. And so I think it worked.
Yeah, absolutely. I think it was a really beneficial way to explain how everything works, because exactly as I said, there was kubeup, and a lot of people were running it, and then it breaks, and everyone was like, okay.
And you know the number one way the kubeup breaks? You run it, you stand back, and you're like, wow, look at this beautiful cluster. 1 year goes by, and your cluster just stops working. And they said, Kelsey, my cluster doesn't work. What's wrong? I said, how long has it been? They said, about a year. I said, oh, your SSL certificates are expired. Because the script only creates the search for 1 year. And someone said, Kelsey, I know the fix. I was like, what is it? Make the search expire in 10 years. I was like, this will help. Because no one knew that there were certs at all. No one knew that that's how the nodes were communicating to the API server. So I think once we explained it well, the ecosystem filled in the blanks with automation tools, debugging tools, and I think that was the right thing to do for them.
Absolutely. Like, one thing what was completely missing was a whole upgrade strategy. It was like, oh yeah, either you figure this out on your own, or like, yeah, let's create a new cluster. But
yeah, just create a new cluster
and migrate your complete workload. In the beginning, what do you think were the key milestones for Kubernetes to stand out in the first 3-4 years?
I think the biggest thing was Mesos was way too complicated. I don't know if you've ever tried. How many people ran Mesos in production? Like, they all used to work at the same company too, all three of you. It was extremely complex. I thought I was pretty good at distributed systems, and I just kept giving up on Mesos. OpenStack, to me, promised that you can run your own cloud. And for a lot of people, that was also too hard because even if you got OpenStack to work, all you had was a bunch of VMs. You still had nothing at the app level. And so the thing that I think made Kubernetes click for people was Docker. Docker did the first thing, which was convince people that you should containerize your application. And once people got a taste of that, then it was like, what's missing? And so I think when Kubernetes said, hey, here's what we think is missing. Keep Docker, keep etcd, keep Terraform if that's what you want to use to bootstrap infrastructure. But here's kubectl apply. So if I had to boil it down to one thing, when people saw kubectl apply, one YAML file, everyone says they hate YAML. But the truth is, YAML gives you a way to express what you want in a data format. Whether it's the perfect data format or not, that's a different discussion. The fact that you can say, I want my app with this much memory, this much CPU, with this volume, and run one command, and in any Kubernetes cluster, for the most part, you get what you ask for. That is extremely hard to do in pretty much every tool at the time. Cloud Foundry, you got an app, but no storage. You couldn't customize networking and load balancing. Or you had something like Docker, which didn't scale across multiple machines, and it didn't integrate that deeply with the cloud provider. So kubectl apply in the cloud, once you saw that, I think at that point you knew where you wanted to go next.
I mean, this brings me exactly to my next question. I mean, nowadays, Kubernetes is not just only Kubernetes. It's a whole ecosystem. I mean, even a whole industry is around this. And when did you realize, like, because a lot of other tools are just C tools, like it was Cloud Foundry with a bit of other tools around. But nowadays with Kubernetes, of course, Kubernetes is still one of the major building blocks of this. But it's not, well, it's the center, but there are a lot of other stuff around this. And when did you saw that this ecosystem can really grow and expand across, over Kubernetes, and a lot more potential could come out there?
Well, to do the work for Kubernetes, to make it work on CoreOS, the first thing I had to write was a cloud provider integration. And this is the component that talks about the nodes, list the nodes, configure some of the networking. And at that moment, I was like, look how easy it is to extend the system. But the one moment was when Brendan Burns, one of the co-founders, when I used to visit the Seattle office where he worked, he was working on this CRD thing, the custom resource definition. And he knew that one mistake that he thought projects like OpenStack made is that there was no way to extend the API in a first-class way. And he believed that it was so important that we get custom resource definitions. Actually, at some point, he was kind of like the only major person that thought this was something that had to happen in order for things to take off. And when you got CRDs, for those that are not familiar, you get to use the same infrastructure Kubernetes uses to describe your API, you get command line tool integration, and you make your own control loop. And when I saw that, I gave a presentation at an Nginx conference years ago. And I was able to integrate Nginx, the web proxy, by creating a CRD and just adding my own little loop called motorboat. And what it allowed me to do, if you were using Nginx, don't change it. All you need to do is allow me to take pods in Kubernetes using the API, and I would just automatically update the Nginx API. And when people saw that, it was like, oh, I don't have to change everything. It's like, no. In many ways, if you're familiar with dynamic versus statically typed programming languages, Kubernetes gave infrastructure a type system. Kubernetes doesn't do anything by itself, actually. You store metadata, and little control loops make things happen. That's all Kubernetes is. And if you look at it this way, you can make any control loop you want. Even in Bash, you can make a little control loop that reads data from the API server and do whatever you want. So you can rebuild Terraform if you want. We see this with Crossplane. You can make a networking system. We see this with Istio. It's that extension API and the fact that we made it almost as easy as writing a shell script that you can actually make your own extensions. That was like the moment where I think it separated itself from all of the other tools.
Yeah, I want to now start opening the floor more to you. So, of course, I can ask a lot of more questions. I have a lot of more written down. So if you haven't voted or start writing down your questions, feel free, and I will ask 1 or 2 more questions, but then we will go to your questions and really start.
Well, they got good questions. You gotta go to those questions. Look at that. That's a really good question.
There. Yeah, I mean, let's start with the first one. What's your view on the future of open source with the Exodus events going on, like Elasticsearch and Terraform?
Man, how many people are professionals in tech that get paid to do work? Look at all the hands. Like, if I asked you to come work on my project for free, you'd be like, what? Why? Right? It doesn't make any sense. But who creates these open source projects? It takes a lot of money to get people at your skill level to work on them full time. It's more than just a logo and putting it on GitHub. There are small bugs, there's compatibility, there are third-party dependencies. There's so much work that goes into these. So if you're HashiCorp, think about it, just walk through the flow. You raise some money, and for years you don't have to make a lot of money. You can just give away things for free because you're trying to build adoption. And then you go from having 10 people on staff to 3,000 people on staff. That's a lot of people that need to be paid. What if I asked you to start paying for Terraform or Vault or any of their tools? Would you pay for them? And what would make you pay for them? And a lot of you have skills that all you need is the open source. You will read the documentation. You even can write code. You can make Terraform better, and you will contribute. Given that kind of cycle, all these companies will go out of business because there is no business if you're not making any money. So these kind of companies that are listed here and being asked about, they're in the profit business, and the people who work for them expect to get paid. So it's a very tricky situation. How do you have a sustainable business if your product is so good that you give it away for free? And there's a lot of companies that do support who are not HashiCorp. I met some of them on the floor earlier today. I think Camp was one of those. They talk about how they provide support to people using open source projects. So if there's other people who can service my project, other people who can contribute to my project, how can I have a sustainable business? It's not easy. So one thing you could try is to force people to pay. And these are experiments, by the way. It turns out they're not always the best experiments. You know, Elastic went and changed their license, and recently they went and changed it back.
I wanted to say, I mean, there's also now the good example that it can turn back with Elastic.
Yeah, but so for running a business, I don't know if there's a good answer for the philosophy of open source. I contribute to open source and I have done it for decades for free. I didn't expect anything in return. But I've also worked at companies where I expected to get paid to work on said open source. And so I think the ideology that these companies changing their licenses are being malicious, I think that's challenging because you can always fork these projects. And I think the last thing I'll say here is like Terraform is a project that I contributed to in the early days of HashiCorp. And I gave those contributions away in the spirit of open source. But I also know people who work on Terraform that need to be paid. And so they changed their license. This is the other side of the equation. Everyone loves open source. But not as many people that love open source contribute actual code to open source and then support the code that they contribute. And this leaves a serious gap. And so when a company changes their license, what are we supposed to do as a community? You ever use GitHub? There's a little button called fork. You fork it. But once you fork the project, now it becomes your responsibility. You have to maintain the project. I don't think people understand what maintenance is. When a company says there is a security vulnerability that needs to be fixed in 24 hours, and you're not getting paid, there is no sense of urgency. I've had my own open source projects. I had one called conf.d, and people started using it for commercial stuff. And someone opened an issue, this needs to be fixed immediately. I was like, according to who? There is no sense of urgency for me. And so now you have this gray area. If you want that level of commitment, then there has to be some motivation. And so for me, I was like, I'm not responding to those. I'm not starting a startup around conf.d. You get what I give. But if you're HashiCorp and you do sign up for that commitment, then you have to honor that, and usually do that by paying people. So we'll see. There's the fork called OpenTofu. If you all will step up and maintain it forever. The day you stop maintaining it is the day that project dies. And then people will go looking for something else. And so I think a lot of people don't understand the responsibility behind these open source projects. So the license is one thing, the responsibility is another. So I tend to thank these companies for the 10 years that they've given us this stuff for free, creating something that is worth being forked, and then we'll see what the next 10 years brings if people actually maintain these actual forks. So that's my position on it. I'm a bit more neutral because as someone who's created an open source project and knows what it's like to have to maintain one, I understand why they make these decisions, but I'm so glad that we get to fork them and decide for ourselves if they should keep going as actual open source projects.
Absolutely, and I think there's no one of the companies takes this easy to say, oh yeah, I just say, change the license. There's a lot of discussion in the background there. You're a big promoter of minimalism. So how does this influence your career and also your whole life?
Yeah, this is a life choice for me because when I was starting my tech career, you don't know how to start a tech career, and then once I'm in it, I'm asking myself, am I gonna have to work forever? Right? You look at people around you, all of this debt, they're competing on who has the best car, they're competing on who has the best house. And then you look at that and it's like, do I want to compete with these people forever? And so I decided that in my early 20s that I would stop competing on the material side of things. And so I discovered this idea of minimalism to be intentional. It's not less stuff. I have more than one fork and spoon. But it's about being intentional with the things I buy and the things I choose to get involved with. That means if I'm going to be doing something, I'm going to be fully committed to that thing at the highest level of excellence as possible and not be distracted by other things. So how does that bleed into your career? If I say I'm going to do something, my goal is to complete the task at a very high bar to the point where people really admire the type of work that I'm doing. So it's really around intentionality and being thoughtful about the things that I get involved in. A lot of things are way too complex for no reason other than I just wanted to do it that way. And so thinking deeply about these things just changed the way I started writing software. The design, the API, who's going to use it, the way it gets released. I worked on CNI, and there was at the time, Docker had a networking API. It was very rigid. It had a lot of key values about what networking meant and how Docker decided to model networking. When I was working on CNI, I said there should be no API. Networking is too complex to distill into one YAML file. So the way CNI works is when Kubernetes starts a container, it passes it to the CNI plugin, and you can do whatever you want. And you only have to return an IP address so that Kubernetes can register it for service discovery. That's it. So if you're Cisco, you can do the same complex networking you've been doing. If you're Calico, you can use BGP if you want. We made the API minimal so that you can do complex things with it. And so that's how it kind of influenced the work that I do.
And on the Kubernetes side, what's your least favorite thing with Kubernetes?
The least favorite thing about Kubernetes is that you all think it's going to change everything. It's the worst part about Kubernetes. You see these teams, they have really great people. They have a lot of deep expertise about how their company works. They know the challenges that their company has. They know about all the other failed projects the company has done and why they fail. And then they see something like Kubernetes come out, new and shiny, and everyone runs around talking about Kubernetes a lot. They talk about it even more than the people that they have, to the point where they think Kubernetes is a substitute from having a good team, a good strategy in general. They just say, we're going to be using Kubernetes. What does that mean by itself? Right? I'm going to be using TCP/IP. What does that mean by itself? It doesn't mean anything by itself. So Kubernetes is a great tool to have in the toolbox, but it's going to be integrated by your team, and that's the only point that it becomes useful. So that's the thing that I hate most about Kubernetes, that people think if they just rub Kubernetes on broken infrastructure, it's going to heal itself. It doesn't.
But do you know why? I mean, it's not just with Kubernetes. I mean, it's a general thing in the IT, like, oh, there's one tool which will change the complete world. And I only see this in the IT, or I see this so dramatically in the IT, not, for example, in other areas.
It's in every area. I've been learning about electrical stuff because I ran new electrical circuits in my home, from the breaker all the way to different floors in my home. And I was looking for a torque wrench, right? So when you plug in the breaker and you put the wires in, you want to torque it to specification so you don't have electrical fires in your breaker box. How complex is a torque wrench? Nope. There's lots of them. And then if you go to WIHA, there's a German tool maker, we make the best torque wrench. And then you look at the video, there's rock and roll music and a guy's turning slowly. He's like, wow, dude, it's a screwdriver. Like, this is it's not so serious. But I think a lot of times when we're craftspeople, we really like our tools, right? Because it allows us to build things. And so our identities become our tools. I'm a carpenter, and they have a logo with a saw, because it represents what I do. So I think a lot of times when people who build things, the tools we use to build things become a big part of our identity. And so I think in IT we see it a lot, because a single person by themselves doing nothing doesn't reflect what we do at work. The minute we bring in a keyboard, the minute we bring in a programming language, it's the way we express ourselves, and then it becomes the thing that we identify. I'm a Linux system administrator, before you even introduce yourself. And maybe that's just something we can deal with by saying people over technology.
You talk a lot with people on conferences, you talk a lot with customers during your Google time, even nowadays. Like, what's the most ridiculous use case Kubernetes is used for, you see there? Do you have something really special in mind where you say, oh yeah?
To me, and this will be the case until it's not, when I see people put databases in Kubernetes, I always like, what are you doing? And the reason behind this is that I don't think a lot of people understand. I've worked at Google twice. Once in my early career inside of a Google data center, where we had these systems that really did a good job of separating state from compute. And I joined cloud, and when Kubernetes was invented, there was no volumes. I don't know if people remember this. In the early days of Kubernetes, there is no concept of a volume. Why? Because a distributed system and POSIX do not mix. Like, NFS is lying to you. You ever get on a server with NFS and it locks? Your write went nowhere. It's gone. So typically, objects stored in the cloud were two things that went together. Remember, the first Amazon service is S3. And once you have S3, you can build all these other primitives off of this. Then people take their database. Kubernetes is not great at managing data. Most people are not good at managing databases either. And so they take the database. I'm like, why are you doing Postgres? Is this your system of record? I was like, yes. OK, what happens if you lose the data? Oh, then we're in trouble. So Kubernetes knows nothing about database. There's no database type. It knows not a lot about what's on your actual volume. Kubernetes is designed to restart a process when necessary and reschedule it to another machine when necessary. In the early days of Kubernetes, I remember people running in databases like, I'm trying to help you. And then they said, no, Kelsey, will totally work. Look at my YAML file. I said, the YAML is not going to help you in production. And they run kubectl to apply, and it works. And then there's a node failure. And we've seen this thing before. We had this reconciliation engine for storage. The node is gone, and Kubernetes cannot mount the storage to another VM. Why? Because the volume controller is also dead. And so now your volume is just hanging out nowhere. Since you don't know how any of this works, you're just on the phone, on the outage, explaining to the people, I have no idea what Kubernetes is doing. All I see is pod is pending. The thing is, if you have an actual database with your system of record, separate it from the apps. We learned this a long time ago in the 3-stack architecture. Load balancer, app tier, database tier. We separate them for performance reasons, security reasons, upgrade lifecycle reasons. People that don't understand this, they upgrade their whole Kubernetes cluster, and it just starts randomly taking down database, then the apps, then they lose their data. There's so little value of doing this that I don't understand why people put in all of this work to do that when you can use a managed database or just a big VM with live migration, actual backups that you test. So that to me, that's my pet peeve of things. Like, it's funny when they do it, because when they lose their data, they say, hey, Kelsey, I think you were right. The data's gone.
And I mean, that's the problem with data. When a cluster is just down and stateless, you can get it up again.
You will learn about state.
Yes.
Where is it?
So looking more into the future, I mean, the standard question, we had it also in the morning when we were chatting a bit, like, what comes after Kubernetes?
So there's two. I remember I came to Germany in Berlin years ago, and the talk was Kubernetes is going to die. And there's people who have Kubernetes tattoos. They're thinking, was this a good idea? 5 years ago, we're still at the top of the hype cycle, and you updated your LinkedIn to say Kubernetes engineer. And now someone is telling you that it's going to go away. So there's a couple schools of thought. Should it go away? Like the Mesos people probably never thought Mesos would go away. The Cloud Foundry people probably thought Cloud Foundry would not go away. But someone somewhere is working on a replacement when the time comes. And so there's a quote that I like the most, which is, it's easy to predict the future when you're working on it. There are a lot of problems with Kubernetes. There's a lot of unnecessary moving pieces to support flexibility. But at some point, we're going to identify some patterns that no longer need to be flexible. And someone's going to make a replacement. And my guess is the replacement will be predicated on what makes Kubernetes hard today. For example, etcd doesn't have indexes. Wouldn't it be nice if you could say, show me the pod where value equals? You can do that with a SQL database. And for how small most of the clusters are in the world, we probably would have been better off using something like Postgres. And there have been attempts to have people replace etcd with actual SQL database and just providing the facade on top, because SQL is pretty powerful and it has been proven to scale. And so it's things like that where all of these things will add up to something new. If 10 years goes by, 20 years goes by, and we're still doing Kubernetes like this, then that's kind of sad, because that means there's no progress. You want to live in a world where there's no progress? We didn't learn anything in the last couple of decades to the point where we're still doing this? So that's what my hope is that someone somewhere is trying to replace this. Because in order for that to work, it actually needs to be better. So that's what I mean by the future of Kubernetes. The people that are working on it are solving problems. Like K3S hints at this. People doing things on edge hints at this. And then maybe one day someone will produce a better implementation of Kubernetes, and maybe we keep the API. We saw this with Apache versus Nginx. There's no reason why this won't happen to Kubernetes too. And when you see it, do not be afraid, because if we would have stopped at Docker, then there would be no Kubernetes. So the lineage will continue.
I mean, 3, 4, 5 years ago, cloud native and Kubernetes was one of the most hottest things in the IT. Nowadays, there's a new kid in town, which is called AI. What do you think? What impact will have AI on running and managing Kubernetes cluster?
One thing I noticed is that being a kid is great because you don't care about any of these things when you're a kid. Seriously, as a kid, you focus on the things that are in front of you. You go outside, you play, you grow and develop, and you learn the things that are necessary to sustain life. That's what a kid does. As adults, we're like, oh, what is the NVIDIA stock price? Do I have some NVIDIA shares? Am I going to get left behind? And it's like you get distracted by these things. So generative AI, this new flavor, I'm ignoring on purpose. I literally don't care what's happening. I can't pay attention to all the things. So for me, I don't feel like I'm missing out. I'm okay. But when we say AI and Kubernetes, let's just think through it. Unless AI is going to create the replacement that I just talked about. But if we're still talking about Kubernetes binaries running somewhere, and you use something like generative AI to create YAML files, I can't be impressed by you creating YAML files with ChatGPT. It's the same YAML files. Artificial intelligence versus real intelligence. Right now, the Kubernetes API sucks. It sucks. There's so many key value pairs to support flexibility. Every custom resource allows you to do anything you want. And if you don't like those, you just create another one. So we end up with this huge array of ways of making decisions. And so when you think about what ChatGPT does, it just gives us a new dialect for telling Kubernetes to do what we want, therefore telling us that maybe it's time for a better API. It could be a GUI-based API. If you really want to write English in the text box and pray that the right thing comes out, then be my guest. I'm going to probably make a lot more money cleaning that up down the road, right? Because all of this reminds me of that kube up script. If you don't know how the thing got made, good luck troubleshooting it. ChatGPT generate kube manifest for all 1,000 of our applications and databases, and it says sure. And then you have a problem in production. What are you going to do? ChatGPT fix it. And if we ever get to the point where ChatGPT can do both of those things, y'all won't have a job. Do you understand what I'm saying? Like, if literally we can just move all of this to prompts, you're done. It's a wrap. So I don't know if artificial intelligence is going to be a complete substitute for real intelligence, but I do like the idea of having it explain things to us. What does this manifest mean? What errors do I have? In my IDE doing better auto-completions, explaining things? 100%, I think that's going to be a great augmentation to the workflow as we do this type of knowledge work.
Absolutely. And you retired from Google. I think you wrote also it will be your last, or it was your last employment job. And with all the successful contributions and you standing in the community, what are your goals and what motivates you and what drives you to do next?
Waking up motivates me. Seriously, a lot of people don't wake up. There's this illusion you have, especially when you're young, that you're going to get 80 years out of life, 100 years out of life. You don't think about the time span. I'm 43 years old. I know people who have died. So I know everyone's not going to get 100 years. So if I get to wake up in the morning, I am motivated by what I get to do that day. I get to choose, though. There's nothing wrong with having a job, but there's a trade-off. I have to go and do what they would like me to do. Now I get to choose what to do. And so the motivation force is, do you know how valuable it is to be able to help someone? That feeling? I meet random people at conferences and they will say, hey, I met a person, they were in prison, I didn't ask why. But during their time there, they were watching YouTube videos. And they were watching my videos about Kubernetes for some reason. They got out, they got a job, and now they were the lead engineer at their particular company. And for this person, they believed that I helped save their life. He found a respectable job, doing something that he learned to love, and he made a career pivot. The power to be able to do that for one person, 1,000 people, 10,000 people, I've had a really great, successful career. There's not much more that I wanted to achieve or prove. I was a distinguished engineer when I left Google. I had a book published. I've been able to talk on the world's biggest stages. But more importantly, I was able to do what the people that wrote the books for me when I was starting my tech career. I read those books, we call it self-study, but you're really learning from teachers you've never met. And I know how much impact it had on my life to be able to make these kind of decisions. And now I get to do the same. And so that's what motivates me the most. So every day I get to wake up, I get to do that again.
Yeah, unfortunately, we're already running out of time. It's every time a really pleasure to listen to you. You are so inspiring. So big applause for Kelsey.